All right, so today we are going to finish up our notes from 5.2, which is integrating stuff with the natural log. Okay, and just remember, the integral of du over u is equal to the natural log of the absolute value of u plus c. All right, so basically, it just gives us another way of being able to pick something for substitution. All right, uh, obviously, if something raised to a power, you're going to pick u to make that. This gives us, if we have a fraction, we can try u as the denominator. Okay, um, so we did all these examples the other day, and we ended at doing tangent. Okay, and if you remember, we did tangent as like sine over cosine. We made u cosine, and we did all of that, and we got some natural log thing. We got d over u. Okay, but you don't have to worry about doing it that way anymore. Okay, so our first example that we're going to do is L's cotangent x. Well, the integral of cotangent. Well, on our formula sheet, we have the integral of cotangent is right there. It's the natural log of sine u plus c. All right, so we don't need to go through and do all of the changing cotangent to like cosine over sine, and you would end up getting the same answer, but save yourself time. And if you see something like that, we're just going to use our formula sheet, and there is nothing after it, so our u is just our x. So it is the natural log the absolute value of sine, it says u, is just whatever comes after it. In this case, it's just x plus c. And there's our answer. All right. So the difference for something like m would be we're going to follow the same rules that we did in all their trig integral ones. If you have one trig function, you make u whatever comes immediately after the trig function. So u is 3x, du is 3dx. All right. We need to have all of du, so I need this 3. So there's my du, but I have to add a 1/3 on the outside. Integral of cotangent u du. All right, so then you would go to your formula sheet, and you would say, all right, well, there it is right here. Cotangent of u du is a natural log of sine u plus c. So we then go and rewrite our final answer as 1/3 natural log absolute value of sine u just happens to be 3x plus c. There you go. All right. So for secant, all right, well, secant, you could make it 1 over cosine and make u cosine, and we're not doing that. All right, we are just going to make secant is the natural log of secant u plus tangent u plus c. All right, so it's secant plus tangent. So it's the natural log of secant u, in this case just x, plus tan x plus c. All right, don't have to go through and just simply look at the formula sheet. All right, go ahead and see if you could try O. All right, so what should happen, you should have made u 2x du 2dx. All right, we're going to add a 2, which means we have a 1/2 on the outside, integral of secant u du. We would then look at our formula sheet, which is going to tell us this. So our final answer is 1/2 natural log the absolute value of secant u, which in this case our u is 2x, plus tangent u, which in this case is 2x again, plus c. And there is our answer. Okay, so you can see here, this is just stuff that was already on our formula sheet. All right, fortunately you don't have to memorize all this stuff. All right, so there's all the 6 basic trig functions. We already knew those. These are some new ones here with all the natural log stuff. Okay, all right, so like I said, all of these are on your formula sheet. All right, so we're going to finish off with doing these examples. A lot of these are trig. We are not going to do this one, okay? Now, not all of these are going to be du over u. All right, so for this one, like I said, they're not all going to be du over u. So you just have to go through. You have a trig. And we have square root of x after that. We also have square root of x as our denominator. So that's a pretty good chance that square root of x is probably going to be our u. Remember, the square root of x is the same thing as x to the 1/2. The derivative of that is 1/2 x to the negative 1/2, right? Which is really 1 over 2 root x dx. All right, so we need all of du. We have the square root of x on the bottom. All right. Oh, there you go. Sorry, my mouse wasn't working for a little bit. I have the square root of x on the bottom already. Add the dx. I need a 2 here. I need the 1/2, right? So if I'm adding 1/2, I had put 2 on the outside. So it's going to be 2 integral. All of this is my du. And I've got cosecant. What is, sorry, not that. This is not part of it. I got cosecant u du. All right. What's cosecant u? I don't know. I forget. So, cosecant u is right here. It is negative natural log cosecant u plus cotangent u plus c. All right. So negative 2 natural log cosecant u, which in this case is the square root of x. See, I can't memorize it. Plus cotangent u, which is the square root of x. Absolute value of that plus c. All right, so you're just using your formula sheet. Apparently my mouse does not want to work today. There we go. Okay. All right, so for q, what can I make q? Well, I got 2 trig functions. I can make it x, I guess. They're the same power, but if you got a fraction, if I make it just x, the integral of that's just 1. It's not really going to get rid of anything. So what if I made it the denominator? Okay, so it's always an option. If it doesn't work, you can always just try the other thing. What's the derivative 2 is 0. What's the derivative of sine? Cosine. So I get cosine x dx. Well, cosine x dx, that is all of that. That is my du. I don't have to add anything. Over, what's this? U. So I have my du over u. What is du over u? It is the natural log of the absolute value of u, which was 2 plus sine x plus c. And there's your answer. Right? All right. For r, what do you think we are going to make? What are we going to make our u? Right. Well, what you should have said is that it is, you have a trig 2 trig functions. They have the same power, so it's whatever comes after it. There's no fraction here at all, so you just make u x cubed. Du is 3x squared dx. I need to add a 3 in there. There's my 3x squared, there's my dx, there's my du. So I get 1/3 integral, all right, of secant u tan u du. Now, if you don't remember what the integral of secant tangent is, you go to your formula sheet, and it's right here. The integral of secant u tangent u is secant u plus c, right? Which means my answer is 1/3 secant of u, which is x cubed plus c. And I apologize. My writing is awful today. Not that it's ever good, but I apologize. All right. So there's r. All right, for t. All right, what are we going to do for t? This is not a trig one. All right. So we basically have 2 options here for t. All right. The option, for letter t to make for a u. The options are you have a fraction and you have something inside. So it's either going to be x cubed plus 1 because it's on the inside, or we're going to make it the entire denominator. Now, if I make it the entire denominator, that's a square root of x cubed plus 1. Then you got to find the square root of x cubed, the derivative of that, by doing the chain rule. So I don't want to necessarily have to do that. So I'm not going to try that one first. I'm just going to try x cubed plus 1. And when I take the derivative of that, see if that helps me out, and I get 3x squared dx, I can add in my 3 right there, which means I have 1/3 integral. So all of this is du. Now, it's not over u, it's over the square root of u. So unfortunately, I can't just do the natural log thing. It's actually, I can rewrite this as u to the negative 1/2 du. All right. And my mouse is driving me crazy. All right. It's one of those days. All right. So I get 1/3, add 1 to 1/2. Negative 1/2 is positive 1/2. You then put a 1 here, a 2 there. So we end up with an answer of 2 parentheses, what was it? X cubed plus 1 to the 1/2 over 3 plus c. All right. So remember, just because we just did du over u, not anything's going to happen to be du over u. This is du over the square root of u. Okay. All right. For u, so we have last 3 here. All right. What happens if you have on the bottom, you have a cosine on the bottom? Well, isn't cosine and secant together? So I could rewrite this as secant squared 3x. All right. So from there, go ahead and finish that. Right? So you should have picked u as 3x because it's what comes after is only one trig function, and you get 3 dx. So I'm going to add in, the dx should already be here, sorry. I'm going to add in a 3, and it means I get a 1/3 integral secant squared u du. And if you don't know what that is, go look at your formula sheet, all right? But it's tangent, so 1/3 tangent of u, which is 3x plus c. That's your final answer. Okay. V. All right. Notice we have no fractions here, so this is all, this hopefully should be some sort of review, and then maybe the integral we need, we can always use the formula sheet. Maybe that's new. Okay. 2 trig functions, different powers. So we're going to pick u is going to be what? Well, it's going to be the trig function and whatever comes after it of whatever has the highest exponent. So the derivative, excuse me, the derivative of cosecant is negative cosecant, keep the inside the same, cotangent, keep the inside the same, times the derivative of the inside, which is 2. All right, so I'm missing a negative and I'm missing a 2. Okay, so what I want you to do is all of this is my du, isn't it? So the only thing I need to add is the 2 and the negative, so that's negative 1/2. All of this is my du, but I had to use one of these cosecants. So it's not cosecant cubed anymore, it's cosecant squared. So it means it's u squared, because that was cosecant was my u. So negative 1/2 u cubed plus c over 3, which gives me negative cosecant 2x to the 3rd power over 6, because 2 times 3 is 6, plus c. All right. And the last one, which is w, once again, we have 2 trig functions. Cotangent is the higher exponent, so let's go with cotangent for x as my u, which means my du, the derivative of cotangent. If you don't know it, it's fine. You can just look at your formula sheet. It is negative cosecant squared, keep the inside the same, times the derivative of the inside. So I need to add a negative 4 in here, which means I need a negative 1/4 on the outside. So there is my du, and there is my du. All right, so that's all du, and I'm just left with u to the 5th. Du, negative 1/4 u to the 6th over 6 plus c. So it's negative cotangent 4x to the 6th power over 24 plus c. All right, so that concludes section 5.2. All right, so with integrals now, we've just added another du over u. We just added another way of doing substitution. So everything you learned before in substitution is all the same. This just gives us another thing to make as our u. We can make u what is in the denominator. And sometimes when that happens, if you get a du over u, then it's the natural log of u plus c. We now have a few new trig things that can pop up that can be used to form the shape. The only thing really new is we now have a new thing to make for u, and we can make it the denominator. And if we get d over u, we recognize that's an easy little formula that we can use from our integral sheet. All right. So I'm going to give you some on the assignment that you guys have to do. It's not going to all just be d over u. It's going to be a mix of all of the integrals. Okay. So it will be good practice. And then we will spend a couple of days reviewing all of this stuff. And then your test will, I think I wrote it on the classroom when your test is, the exact day for your classes. If you guys have any questions, please do not hesitate to reach out. I hope all of you guys are doing well.